Welcome to Data Driven. We are a group of students at NC State University in the Data Analytics program. The following pages showcase our work within certain areas of business analytics. We pride ourselves on the upscale quality of our work and hope you enjoy. Starting off, we're going to talk a little bit about data. Over the last few years, data has become more advanced and applicable in various industries. Companies and individuals can now use data to enhance their product's position and even revenue. The three levels of data are descriptive, predictive, and prescriptive. All of this starts with descriptive analytics. This form of analytics provides relative information regarding past performance. This can be produced in the form of data queries, reports, descriptive statistics, data visualization, and what-if analysis. After you analyze the past performance, a company starts to forecast for the future. This is done through predictive analytics. These models predict the probability for the future and/or the impact of certain variables on one another. The use of these analytics include data mining, simulation, and forecasting. They all provide a more competitive advantage than descriptive analytics alone. The most complex and competitive form of analytics is prescriptive analytics. These numbers help indicate the next step for companies in terms of investment, while also considering various constraints. Companies choose to look at these models, which include optimization, decision analysis, and simulation. Our About Us tab located at the top tells a little bit about ourselves. Please refer to this for any contact information. Moving along, we'll start with our data projects. These pages highlight the skills we've explored in our business analytics class at NC State. Through these projects, we have learned how to manipulate data in various environments, including Excel, SAS Visual Analytics, and Tableau. Many of us have also furthered our knowledge through various internships as well as self-learning outside of the classroom. To start us off, Angela is going to talk a little bit about data mining.
Data mining is the computer-assisted process of digging through and analyzing large sets of data and then extracting the meaning of the data. Data mining tools predict behaviors and future trends, allowing businesses to make proactive, knowledge-driven business decisions. Data mining tools can answer business questions that are very time-consuming to complete. For businesses, data mining is used to discover patterns and relationships in the data in order to help make better business decisions. Data mining can help spot trends in market segmentation, customer churn, fraud, and even help produce new business opportunities. Using massive computers, companies dig through large volumes of data to discover patterns about their customers and products. Traditional query and report tools have been used to describe and extract what data is in a database. The user forms a hypothesis about relationship and verifies it or discounts it with a series of queries against the data. New data mining techniques make this process several times easier. One data mining technique is hierarchical data mining, which is a form of cluster analysis. Clustering organizes data by grouping similar objects together and is a common technique in statistical data analysis as well as exploratory data mining. To show how clusters are merged, dendrograms split up data objects into several levels of nested partitioning to form a tree of clusters. Many industries currently use data mining to gather several forms of information. AT&T, Target, and American Express are among the growing ranks of companies implementing data mining techniques for sales and marketing, as well as healthcare organizations who are examining medical records to understand trends of the past so they can reduce costs in the future. The next one is data visualization. Data visualization is the presentation of data in a pictorial or graphical format. This enables decision makers to see analytics presented visually to help grasp difficult concepts or identify new patterns. New technologies allow for interactive visualization so you can drill down into specific detail. This allows the user to take the concepts a step further and change how data is seen. This concept is very important because of the way the human brain processes information. Charts and graphs are easier for non-data scientists to process instead of portraying in a series of spreadsheets or reports. The visualizations are also easier to maneuver in order to clarify which factors influence customer behavior and predict sales volumes. It is currently being used in businesses to address problems in a timely manner in clear, cohesive ways. While also being a faster alternative to the normal spreadsheet approach, the idea that complex and extensive amount of information can be depicted in a graphical way is great for decision makers with less knowledge of data. The visualizations also help businesses recognize parameters that are highly correlated and identify relationships to focus their influence.
Now we're going to turn to Shane, actually, for decision trees.
Decision trees provide a graphical representation of the decision-making process. These decisions may occur over a specific period of time in a logical progression or an analysis of specific factors. In the example above, we are trying to determine what factors that lead to customers buying organic or non-organic products. After decisions are made, various outcomes could be the result. There are various parts to a decision tree, including decision nodes, chance nodes, and branches. The decision node is what will occur, and the chance nodes represent the alternatives. Branches connect the nodes. The branches leaving the decision nodes correspond to the states of nature. Furthermore, outcomes are shown at the end of the possible outcomes. With this visual representation of the probabilities, it is a lot easier to weight the costs and benefits of specific decisions. Next, I'll be talking about linear programming. Linear programming, also known as optimization, is a method used in computer modeling to find the best possible solution to achieve an outcome based on some set of constraints or various linear inequalities. Constraints are forms of limitations that may suggest things such as how much of a certain item can be made. In the real world, linear programming enables industries and businesses to find optimal solutions to economic decisions. Usually this pertains to maximizing profits and minimizing costs. Many industries use linear programming to increase the revenue of their operations, solve business problems, and improve planning. Next, we'll be talking about Monte Carlo risk simulation.
The Monte Carlo simulation that we completed takes predictive analytics one step further. Not only does the simulation provide insight on what might happen in the future, it also lets the user know how likely it is to happen. Through the use of probabilities and ranges, Monte Carlos allow businesses and decision makers to make more informed decisions about how the future works. This simulation is commonly used in forecasting models, risk management, project management, and other cost management situations. By inputting probabilities of different variables in a model, the simulation will run thousands of times and output a most likely scenario along with minimum and maximum scenarios. To learn more about the case and its specifics, feel free to check out our page, but we will add that we found the initial scenario in NPV of $397,939,930.57. Following the initial scenario, we increased the market size by any amount that you can increase the NPV. When we doubled the market size, the NPV doubled, and fewer R&D costs increased the NPV, and a larger growth factor contributes. We found that there is a 5% chance that the NPV will not be positive over the next 5 years, and the mean of this is $421,196,929.78. We also found that there's a 15.9% chance that the product will show a cumulative net profit. Next, I will be talking about multiple linear regression analysis. Multiple linear regression attempts to model the relationship between two or more explanatory variables and a response variable. This type of regression makes a line of best fit that fits a linear equation to the observed data. When doing so, every value of the independent variable is associated with the value of the dependent variable. There are a few different ways to use multiple linear regression. You can use it for identifying the strength of the effect as an independent variable has on dependent variables. It can also be used to forecast effects or impacts of changes to the dependent variable. Multiple linear regression can also be used to predict trends and future values, as we did in our cases used in class. Based on various cases, we were asked to predict future values using variables that were relevant to the final outcome. That first started with figuring out the correlation between the certain variables to decide if they were relevant or not. Next, Morgan will talk more about time series analysis and forecasting.
Time series analysis and forecasting are normally used in monitoring processes or a business metric. The difference between modeling data and time series methods is the fact that time series accounts for the data to contain seasonality and trends. There are several different types of techniques, including the moving average and exponential smoothing. The moving average is the simplest way to smooth the data for forecasting, but is only useful when there are no trends in the data, since it weighs all the past observations equally. As in exponential smoothing, it's used to exponentially decrease weights as the observation gets older, so only the most recent observations are more relative to the model. There are also more parameters to be determined, so that helps assign the weights to the observations. Finally, we'll go to our last data project, logistic regression. Logistic regression models are responsible for finding the association between multiple categories by estimating the correlation between variables. Multiple measures and categorical variables can serve as inputs for these models, and the R-squared value can depict the goodness of fit. It can also serve as a probability simulation by measuring how likely simulation variables correlate. Logistic regressions are applicable in industries all across the globe, from healthcare to finance. In our case, age and affluence grade were the most significant measures from the data provided, so those were the only continuous effects. We used the inputs variables of age, gender, and recent purchased items, resulting in an R-squared value of 0.1481, which shows a weak relationship between the variables and organics purchased. Continuing on, the lift chart shows two lines, one that represents the model you built and one that represents the best achievable model, or a perfect classifier. When the model line is closer to the best line, especially in lower percentiles, the model is better. As restated, the lift is the ratio of the percent of captured events within the percentile bin to the average percent of responses for the model. In relation to the case, the lift value means that if the supermarket chain sent out coupons to the top 20% of customers selected by this model, it could expect to see 1.2056 times more customers purchasing organic products than if the same number of customers were randomly selected. Continuing on, the curvature of the chart has a steeper initial slope, then levels off, suggesting that the predictive accuracy of the model is good, not excellent. The maximum separation, or KS statistic, is 0.4716 and is located at about the 0.2 specificity. The model becomes a better predictor for error after the 0.4 sensitivity region, where it reaches a sensitivity higher than 0.82. Using the variable inputs resulting in the R-squared of 0.2335, there were 63,080 customers who were incorrectly classified as not bought, or also known as a false positive. 214,396 customers were identified as a false negative, meaning they did not buy anything. This model should be refined in light of this, because there is higher percentages of customers who are identified as false negatives than true positives. The grocer should be more concerned with what parameters customers who buy products are classified as. Closing out our project is our Data for Purpose blog. There are various different industries, including the food industry, healthcare, makeup, and sports, all using analytics right now to thrive their businesses and industries into the future. Our last page is the Data Divas. Check backs once we drop our hot new single, Data, at 1 p.m. April 28th, 2K16. This is by Savage Shane and the Data Divas.
Holla!
Thank you for your time. We appreciate it.